Good morning, dear students. In yesterday period, we were discussed about chemical properties of metals. At the time, how reaction is takes place in between metals and oxygen, what they can form. It means metal plus oxygen can give rise to metal oxide in the process of heating, and also some exceptions are also there. They are termed as what? Amphoteric. It means metal oxides which are react with both acids as well as bases to produce salt and water are known as amphoteric reaction. Afterwards, order of reactivity of metals with oxygen and reaction of metals with metals. When metals are react with water, they can produce water, metal oxide as well as hydrogen gas. Afterwards, metal oxides are dissolved in water, they produce metal hydroxide. And some concern examples. Afterwards, reaction of metals with acid, it means dilute HCl as well as dilute sulfuric acid, it means HuSO4, react with metals to produce respective metal salt as well as hydrogen gas. Afterwards, how reaction is takes place with dilute HNO3, it means reaction of metals with dilute HNO3, their hydrogen gas is not evolved when a metal react with nitric acid. This is due to strong oxidizing nature of nitric acid. It oxidizes the hydrogen produced to water and itself get reduced to any of the nitrogen oxide. It may be N2O, NO or NO2. But magnesium and manganese react with very dilute HNO3 to evolve hydrogen gas. And afterwards, reaction of metals with solutions of other metal salts. Dear students, let us see today's class the reactivity series of metals. The reactivity series is a list of metals arranged in the order of their decreasing activities. Yes, my dear students. Okay, upper side is termed as what? More reactive elements or more reactive side. Yes, and lower region is termed as what? Less reactive side. Okay, let us see what is meant by more and what is meant by less reactive element. Yes, my students, on the basis of their relative tendency to lose electron and their reactive nature, metals are arranged in series. This series is called activity series or reactivity series of metals. Yes, it is meant by reactivity series. On the basis of their relative tendency to lose electron and their and their reactive nature, reactive nature, metals are arranged, metals are arranged in a series, in a series. This series, this series is called reactivity series of metals, reactivity series of metals. Yes, my dear students, on the basis of their latent tendency to lose electron and their reactive nature, metals are arranged in what a series. This is called reactivity series of metals. Here, the metals that are kept are placed above hydrogen are called, above the hydrogen, yes, above the hydrogen are called, yes, above the hydrogen. Yes, above the hydrogen are called what? More reactive elements, and the metals that are placed below hydrogen are least reactive metals. Yes, my dear students, it means reactivity series starts from what? Potassium. Okay, from more reactive side to less reactive side, or it is termed as what? Activity series of metals. Yes, my dear students, here most reactive or more reactive elements are, first one is potassium, sodium and calcium, magnesium, aluminium, zinc, iron, tin and lead. Yes, they are termed as what? More reactive elements. Yes, my dear students, they are arranged in what? Decreasing order. They are arranged in decreasing order. Decreasing order. Okay, arranged in decreasing orders. Decreasing order. Yes, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, and below the hydrogen, copper, mercury, silver and gold. Okay, my dear students. Okay, four elements are termed as what? Reactive metals, and above hydrogen they are termed as what? More reactive elements. Yes, my dear students. Here hydrogen have non-metallic property, but due to its electropositive nature, it has been placed in the reactivity series. Yes, my dear students, remind it and also make a point concerning your examination. Hydrogen also have non-metallic property, non-metallic property, non-metallic property, but due to its electropositive positive nature, it has been placed in the reactivity series. Yes, all of you already know. Electropositive metals are termed as what? Electropositive. Yes, and non-metals are said to be what? Electronegative ions. But hydrogen have what? non-metallic property, but it is termed as what a electropositive nature. That's why it is placed where in an reactive series. Okay, my dear students, after knowing about reactivity series of elements, okay, mind it once again. Reactivity series, okay, more reactive side, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin and lead above. Okay, they are termed as what a more reactive. Yes, below hydrogen there is only 4 elements: copper, mercury, silver and gold. These are termed as what a less reactive. Here also hydrogen is placed where in modern periodic table. Why? Because they possess electropositive nature. Yes, my dear students, let us see. After completion of metals, next discussion point is non-metals. 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 Yes, those elements which form negative ions by gaining electrons are called non-metals. Yes, my dear students, those elements which form negative ions by gaining electrons are called non-metals. Yes, metals are, my dear students, they are termed as a positive and losing electron are called metals. But here the elements which form negative ions by gain what electrons are termed as non-metals. Yes, examples. Okay, they are solid or gases, but some exception is there. What except bromine is in the state of what liquid. Clear? Mean non-metals are solid as well as gases, but exception is there. Bromine is seems in the form of what liquid. Yes, my dear students, let us see physical properties of non-metals. Physical properties of non-metals. Physical properties of non-metals. Malleability or ductility. First one is malleability and ductility. Non-metals are neither malleable nor ductile. That is, they cannot be beaten into thin sheets or drawn into wires. Yes, my dear students, it means they are non-malleable and non-ductile. Why does not be here? Does not or cannot be beaten into water, thin sheet as well as drawn into wires. Yes. Second physical property of non-metal is brightlessness. or brittleness, not brightlessness, brittleness. First one is malleability and ductility, second one is brittleness. Yes, my dear students, non-metals are brittle in nature, but metals are hard in nature. Yes, they are brittle in nature. Brittle in nature. Brittle in nature. For instance, sulfur is brittle solid. It is hammered, it breaks into pieces. Yes, exception is there, my dear students. Yes, sulfur is a brittle solid. When we hammer water, sulfur, it breaks into a pieces. Next, third physical property is physical state. Physical state. Most of the non-metals are soft when in the state of a solid. Only diamond and allotropic form of carbon is the hardest known substance. Yes, my dear students, here most of the non-metals are termed as what? Soft when they are in the state of what? Solid. But carbon, in a carbon allotropy is a diamond. Diamond is termed as a one of the allotropic form of a carbon. It is hardest substance. Exception, most non-metals are soft except diamond. Okay, it is the hardest substance. Yes, fourth one is luster. Fourth one is luster. Non-metal do not have luster. It means does not have a shining surface. However, diamond, graphite, okay, and iodine have luster even though they are non-metals. Yes, my dear students. First of all, they does not have non-metals, do not have a luster. Non-metal do not luster except diamond, graphite and iodine. They are termed as what? Shiny. Okay, and fifth one, electrical and thermal conductivity. It means electrical heat conductivity. Yes, non-metals are generally poor conductors of heat and electricity. Yes, they are poor conductors of heat and electricity. Except graphite. Yes, my dear students, here graphite is an allotropic form of a carbon and it is a good conductor of electricity. Yes, graphite rod are used. Good conductor of electricity. Good conductor of electricity. Yes, my dear students, last physical property, melting and boiling point. Melting and boiling point. Yes, generally non-metals have low melting and boiling points, but non-metals that are solid have comparatively higher boiling points. Okay, non-metals have solid state have what a comparatively higher boiling points. Example B, Si and C. Okay. boron, silicon and carbon. Yes, my dear students, here non-metals have low melting and boiling boiling points. Okay, let us see one by one. Physical properties of metals. First physical property is malleability and ductility. Okay, non-metals are non-malleable and non-ductile. Why? Because neither malleable nor ductile, because they cannot be beaten into thin sheet and drawn into a wire. And brightlessness, non-metals are brittle in nature. For instance, sulfur is brittle solid. If it is hammered, it breaks into pieces. Third, physical state. Most non-metals are soft. Some exceptions are there. Diamond is hardest substance and allotropic form of a carbon. And luster. Non-metal do not luster. It means does not be have what a shining surface, except diamond, graphite and iodine. Okay, these three are they have a shining surface. And electric and thermal conductivity, it means heat and electrical conductivity. Non-metals are poor conductors of heat and electricity, exception, it means except graphite. Graphite is termed as what a good conductor of electricity. And melting and boiling point. Non-metals have low melting and boiling points. Yes, my dear students, these are the what are the main physical properties of non-metals. Here important point, the gases like nitrogen, oxygen, carbon dioxide etc., which constitute air are all poor conductors of electricity. Yes. Let's see chemical properties of non-metals. Chemical properties of non-metals. Yes, non-metals do not react with water, steam or dilute acid because they act as an electron acceptor and cannot supply electrons to the H plus ions of acid to reduce them to hydrogen gas, but on heating readily form oxides or salts with concentrated acid. Yes, my dear students, first of all, non-metals do not react with water as well as steam and dilute acids. First point, non-metals do not react with water, steam and dilute acids because they acts as an electron acceptor and cannot supply electrons to H plus ions of acids to reduce them to hydrogen gas. But on heating readily form oxides or salts with concentrated acids. Yes, my dear students. It means when readily heating form oxides or salts with concentrated acid. Yes, my dear students. They can form water, oxide as well as salts when react with water, concentrated acid. Yes, take an example. Sulfur plus sulfuric acid. It is then concentrated. The process of heating can give rise to sulfur dioxide plus water. Yes, my dear students, same way sulfur react with concentrated acid, concentrated HNO3 on readily heating, it can give rise to H2SO4, aqueous solution of H2SO4 plus 6 atom of nitrogen dioxide plus 2H2O aqueous. Yes. Non-metals also show displacement reactions like metals. Yes, my dear students. Take another example. Chlorine, sodium bromide, react with sodium bromide, it is a liquid, can give rise to sodium chloride as well as bromine. Yes. Yes, my dear students. Let us see a next discussion point, how a reaction takes place between metals and non-metals. It means ionic bond formation. Reaction between metals and non-metals. Okay, it is termed as what? Ionic bond formation. Each element wants to have a completely filled valence shell, that is, wants to have either 2 or 8 electrons in their outermost shell. 2 means duplet configuration, 8 means octet configuration, where in an outermost shell of an element. Metals have a tendency to lose electrons and non-metals have a tendency to gain an electron. When metals and non-metals react with each other, then both of them tries to achieve completely filled outermost cell by the transfer of electron. Yes, my dear students. First of all, metals have a tendency to lose electrons, and non-metals have a tendency to gain electrons, when metals and non-metals react with each other, then both of them rises to achieve completely filled outermost cell, by the transfer of electrons. Yes, my dear students, when metal as well as non-metal react with each other, what happen? Then both of them achieve completely filled outermost cell by the transfer of electrons. It means octet as well as duplet configuration. Example, electronic configuration of sodium is electronic configuration of sodium Na11. Okay, sodium is termed as what, my dear students? It is a metal. Yes, 1s2, 2s2, 2p6, 3s1. It means K cell 2 electrons, L cell 8 electrons, and M cell only 1 electron. And in order to complete its octet, that means 8 electrons in the outermost cell, it is easier for sodium to lose 1 electron from the M cell rather than accepting 7 electrons in it. Yes, my dear students, it means here 1 electron is loose from a sodium. Why losing 1 electron and combined with 7 electron, what happen? The formation of octet takes place. Yes, my dear students, if sodium and chlorine react with each other, then the electron lost by sodium is gained by chlorine, Na plus and Cl minus, as formation of sodium chloride. Yes, it means here two elements are combined, sodium as well as chlorine. Yes, it is an electropositive, Na plus Cl minus, chlorine is an electronegative. Yes, my dear students, if sodium and chlorine react with each other, then other than electron lost by sodium is gained by chlorine, Na plus Cl minus. Ion being positively charged and attract each other and held by strong electrostatic force of attraction to exist as NaCl. Okay, thus an ionic bond is formed between them. It means, observe here carefully, Na 2 8 1, yes, according to electronic configuration. K cell 2 electron, L cell 8 electrons, and in an M cell only 1 electron. Yes, what is happening here? Na plus, it means 2 as well as 8, it means completely filled cells and lose 1 electron. Yes, it is. Sodium is a cation. Sodium is cation. Okay, the same way Cl plus E minus Cl 2 8 7 2 8 7 E minus, it can use as to what? Cl minus 2 8 8 2 8 8 when it gain 1 electron from a sodium, 1 electron from sodium, 7 plus 1 is equal to 8. Yes, my dear students. Chlorine electronic configuration, Cl 17, 1s2, 2s2, 2p6, 3s2, 3p5. Yes, K cell 2 electron, L cell 8 electron, and in an M cell 7 electrons. Yes, M cell in 7 electrons here. K cell 2, L cell 8, and M cell 7 electron. Na plus Cl 7. Okay, 1 electron is gained by a sodium. What is formed here, my students? Na plus and Cl minus. Okay, 2 4 6 7 and 8. Okay, Na plus as well as Cl minus. Therefore, it is Na plus Cl minus, or it is termed as a NaCl, sodium chloride. Yes. In today's class, we all are discussed about the reactivity series. It means more reactive elements as well as less reactive elements. Above hydrogen, they are termed as a more reactive elements. Below the hydrogen is termed as a less reactive metals. Afterward, what is non-metal? The elements which form negative ions by gaining electrons are called non-metals. Non-metals are solid or gases. Some exception is there, liquid state bromine is present. And afterward, physical properties of non-metals. It means non-malleable and non-ductile, non-brittle in nature. Brittle in nature. Most of non-metals are soft except diamond, and luster do not luster, but some exception is there. And electrical heat conductivity, melting and boiling point. Afterwards, chemical properties of non-metals and reaction between metal and non-metal. It means ionic bond formation. It means ions are get participate in a chemical reaction. Yes, thank you, students.